Hello, welcome to another Ginger Mathematician video. So this is part 2 in my series of solving equations. And just to remind us what we did last lesson to what we did yesterday. So we had our starter to reinforce our knowledge of collecting like terms and expanding brackets. And we went through the answers briefly. Then we did our step 1, which was to solve equations by looking at them. So if we take question 4, for example, something minus 4 is 2, well, the something has to be 6 for that to make sense. And I gave you the answers to those, so you can check your work and mark it as we go along. And we had some examples of that. And then in step 2, then we started looking at this method. So where we used arrows on both sides in order to simplify our equation until we got to an answer. And sometimes we even had to know our 14 times table in order to work that out as well. If you get stuck on things like that, for example, you've always got your calculator. So I've got my lovely GDC here, which will calculate these things. But a scientific calculator will work perfectly fine for you. So let's get started on what we're doing for today. So I've got you another starter. This is quite a varied starter. So it starts quite easy, but then gets hard towards the extension. So I've tried to cater for all abilities with this particular starter. So this will take you a bit longer than what you did last time. So give yourself about 5 to 10 minutes. Make sure you solve those and make sure you complete them and show you're working. Right, I'll give you your 5 minutes. Off you go. Okay, hopefully you've paused your video for 5 minutes to go through those questions. So let's go through. So m plus m plus m, well, I have 3 lots of m, so that's my answer here. However, if I do m times m, that gives me m cubed. So these two here in particular, you'd be aware of the difference. So when we're adding, then we have a big 3 here and then an m, whereas when we're timesing with m, then we get m cubed. So we get a small 3 here. This is a really key definition to learn. Okay, question 3. So we multiply the numbers. So 4 times 5 is 20, and then p cubed times p squared, or we add the indices, and that's going to give us p to the power of 5. So we get 4 times 5 is 20, p cubed times p squared, or we add the indices, add the small numbers, and we get p to the power of 5. Questions 4 and 5 we looked at in the previous starter as well. This is where we expand the brackets by using what I call the hook. So we multiply the 7 by both things. So we get 7 times b is 7b, 7 times minus 4 is minus 28. And we do exactly the same process here, but we just have to be a little bit careful with this. So we get 6d times d. Well, d times d, like over here, is d squared. We have a 6 in front. Then 6d times 3 gives us 18d. So those are our answers there. Don't know if I have an eraser. I do have an eraser. There we are. So you can see that in more depth. Very good. And then we have some equations, which we actually started looking at in our very last video. So 2x plus 7 is equal to 19. Well, we do the opposite of what we see here on both sides. So the opposite of plus 7 is minus 7. We minus 7 on both sides. This cancels, leaving us with 2x. 19 minus 7 is 12. And then how do we get rid of this 2? How do we remove it? Well, we do the opposite. So we divide by 2 on both sides. Therefore, we get just x, which is what we wanted. And 12 divided by 2 is equal to 6, like so. I would expect most students, if not all students, to be at this stage with their equations. So that's exactly the kind of question we looked at last time. I put some extension questions here. I'm not going to go through the answers here, because I'm going to go through these as we do our lessons, okay, for lesson 2 and lesson 3. But these were more of a challenge. However, I'll still give you the answers. So x is 20 here, and we get x is 38 here. And this one, this is, towards as tough as it gets at year 7. Particularly question 2 as well could be considered a little bit tougher. So this is x is 2, and then the expansion here, so you have to collect like terms. This is why we get 3t squared minus 3t. And this one, we have to expand the brackets and then do what we did in question 9. So we expand the brackets in the same way we did question 4, question 5, and then we solve to get x equal to 4. Okay, very good. But make sure you can do at least questions 1, 2, 4, 5, and 6. Those are the key focus questions. In fact, I will even highlight that. So this one here, 1, 2, 4, 5, and 6. If you're finding any of those questions difficult, then I really do recommend you go back to my first video. So go back to video 1, to part 1, and go through those again. There is no problem in going through that again and again until you're really understanding those key ideas, those key concepts. Because part 2 is going to really build straight on from part 1. So you need to understand part 1, and in my starter, that would be questions 1, 2, 4, 5, and 6. Okay, but if you find that absolutely okay, we'll move on to step 3 of my understanding equations. And this is my third step. So I can confidently apply a method to solving equations. That's basically step 2. But this time when the answer is not a positive integer. So I'll give you 5 seconds to have a think. What does the word integer mean? Okay, hopefully you all answered this question correctly. Integer just means a whole number. So we'll see with the answers to these questions, they will not be a positive integer. That is, these answers will have a negative answer, -5, -10, -12, okay? So that's what we're going to look at here in this particular question. So let's do some examples. So we've got, first of all, there we are, that's better, 2x plus 8 equals 2, and then 3 equals 6p plus 21. So we've got examples. So make sure you're writing this as well. It's always good to keep very neat notes, know exactly where your examples are. So when you come to revise, and that will be coming along, then you need to know exactly what you're revising from. So go back, so 2x plus 8 is equal to 2. So let's pop that in. 2x plus 8 is equal to 2. 2x plus 8 equal to 2. I've got a trackpad. This is a little bit easier than using the mouse, but I think the mouse is perfectly fine for these questions. Right, so we approach this in exactly the same way that we did last time. So I'll get my green pen out this time. There we are, very green. And then we need to think, okay, we've got plus 8. What's the opposite of plus 8? Well, that's going to be minus 8. So we minus 8 on both sides of the equation, like so. And remember, this 8 cancels with this 8. So we're left with just 2x. So let me pop that in. So just 2x. Remember, the minus 8 here and this plus 8 cancels. And then we do the same to the other side. But this time, it's the other way round. Last time we looked at 8 minus 2, or similar. This time, we do 2 minus 8. So if you use your number line, so you start at 2, and you're going to go back 8 spaces. So 1, 2, 3, 4, 5, 6, 7, 8. So we use our number line, that gives us 1, 0, minus 1, minus 2. You can probably see where this is going. Minus 3, minus 4, minus 5, and then our number that we wanted is minus 6, because we're going to, draw an arrow here, minus 8. So 2 minus 8 is equal to minus 6. So notice our answer here is a negative number, because we're minusing a bigger number from a smaller number. So we get here minus 6. So if you're not sure about that, go through what I just said in the last 30 seconds, 1 minute, and make sure you're happy with why this is minus 6. Then, after that, what we're going to do is the same process we did before. So what's the opposite of timesing by 2? Well, that's going to be dividing by 2, and making sure we do that to both sides of our equation, like so. These two cancel, that's the whole point. So we're left with, get the red pen out, there we are. Usually red pens are quite scary, particularly from teachers. So x is equal to, well, let's figure this out. So minus 6 divided by 2, well, 6 divided by 2 is 3, and a minus divided by a plus is equal to a minus. So we get the answer of minus 3. If you're not sure about your negative numbers, then by all means review them. When I taught this in Year 7, we used a table. So we had a table for dividing and multiplying. A minus divided by a plus was a minus. A minus divided by a minus was a plus. So look at those notes from September, October. You'll find those very useful. Okay, and now let's look at example 2. So let me draw a nice clear line so you can see where example 2 is. And let's go back to what it is. So 3 equals 6p plus 21. Okay, so 3 is equal to 6p plus 21. 6p plus 21. And this is kind of the mirror image of the example I did in solving equations part 1. You'll notice the p is on a different side of the equation, but we'll deal with it in exactly the same way. We'll flip at the end. But first things first, we've got some algebra to do. All your favourite word, I'm sure, at home. So let's have a look. So 3 equals 6p plus 21. So we look at the number next to the p. What's the opposite of plus 21? Well, that's going to be minus 21. And we do that to both sides of the equation, like so. So let's work this through. So this minus 21 cancels with this minus 21. So we're left then with, equals always stays there, equals 6p. Notice my equal sign actually does not change through the entire calculation. It stays in exactly the same place. And that's a good habit to get into. All you're doing is manipulating both sides, but the centre, the equals, doesn't change. And when you go to inequalities, you'll see that can change slightly, but that's in the future. Let's look at this then. So we've got 3 minus 21. Okay, well we can use our number line like last time. So we can go 3 and then go back 21 spaces. Another way of doing this is to do 21 minus 3, which is 18. And then realise, because you're taking away a big number from a small number, then we put a minus in front. So I know some of you learnt it that way as well. So I've shown you the two alternatives. You can use a number line if you find that easier, or you can go, okay, 21 minus 3 is 18, but remember, okay, I'm taking a big number from a small number, so that's why it's minus 18. And again, we treat it in exactly the same way we've done the previous questions. So let's carry on. Make sure you write these examples down exactly as I do them. So we've got 6 here. What's the opposite of timesing by 6? Well, that is dividing by 6, and we do that to both sides, like so. And then this 6 is going to cancel with this 6. Once you get comfortable with these, you can almost relax into the solving, So this 6 disappears, so you're left with just p. And now minus 18 divided by 6. Well, 18 divided by 6 is 3. And then a minus divided by a plus is equal to a minus. And at this stage, we have an equal sign, so we can just flip the equation like so. So it looks very similar to what we just had. So we get this. Now, one thing you can do to check your answer is to essentially substitute, that means replace, the p with minus 3 in your equation. So this is a good check that you can do. So if we put p is minus 3 into our equation, well, 6 times minus 3 is minus 18. Minus 18 plus 21 is equal to plus 3. So it definitely works. And we can do the same check with question 1 or example 1. So x is minus 3, and minus 3 times 2 is minus 6. Minus 6 plus 8 is equal to positive 2. And we know we've got the right answer. It's a lovely feeling in exam. If you can substitute back and guarantee you've got the right answer by checking, then you've got 3 marks, 2 marks, however many marks the question is for yourself, and you know you've got those marks in the exam. It makes you feel very good on the inside. Yeah? As we say in German, it makes you feel very wohl. Yeah? So it is worth checking these things. Right, so you know what's coming up now. So this is step 3. We don't want the answers yet anyway. So we've done question 1 and question 2. So let's tick that off. So this one's been done and this one's been done. So give yourself 5 or 10 minutes. Work through the method logically. There is no point writing the answer straight down. We are teaching you good habits now, so when you get to harder questions, you'll see, particularly in part 3, it is worth doing this. Okay? And your challenge question, have a think how you want to express this. All I'm going to say for you for the challenge is you can write this as a fraction or a decimal. Okay, give yourself a good 10 minutes on this activity. Okay, well, hopefully you've got all the answers. I'm going to give you those now, so you can check your answers. So notice question 14 and 15, we've got a negative fraction as our answer. So I've written the fractions, for example, as 4/3, okay, or 8/6. You could simplify these fractions as well. So if I take question 4, for example, let me just take this one. So v was 8/6. But of course, you can always simplify this by dividing by 2. So we get 4/3. So I will accept both answers. If you've got 8/6, that's fine. The best answer, so to speak, is 4/3. Likewise, if you wrote this as a decimal, so that's 1.3 recurring, in this particular example, then that's okay too. Try and get into the habit. I'm trying to teach you good habits for later on in your mathematical career, when you get to iGCSE and beyond, to write it as fractions. When we come to do equations of straight lines in year 10, year 11, it's often useful to write them as fractions so they simplify easier. So that's essentially the reason. I like to try and give you a reason why we're doing these things. And generally when we're manipulating equations of straight lines, writing things as fractions make your life easier. Just trust me on this one. Definitely trust me. Question 8, of course, is 0, because once this disappears, 8 is equal to 8. So that's why that works as well. Alternatively, you could write these as a mixed number. So if I take question 15, for example, so d is equal to minus 9/5. This can be written as a mixed number. So how many 5s go into 9? Well, 1. Remainder, well, 9 minus 5 is 4. And again, we keep the denominator the same. So we get 1 and 4/5. And don't forget the minus in front. So again, I'd also accept that. Or if you had minus 1.8, some of you love decimals, try and avoid it. That's also okay as well. Okay, so let's move on to step 4, which is where people have been very happy so far. You've got a method, you work your way through it, you've practiced the method, etc. Where some students fall down, I've talked to many students young as year 5 and year 6, is when you get these so-called word problems. Okay, you have the arithmetic there in order to do the questions and the algebra, but when you get a worded problem, that's when it gets trickier. But I will try and help you through an example of a worded question, and I will go through them more carefully, so I know students in particular find these challenging. So, my step 4. I can form equations from a word problem and then solve them. Now, we've dealt with the solve part, but the real difficult part, so the way we get the higher grades, is be able to form an equation from a word problem. So, let's take our example. A gardener plants M lots of cabbages. Now remember, M is just a number, but we don't know what that number is, yeah? So I'm going to literally write just a number. Okay, don't let the letter put you off, so to speak. It is just a number. Just keep that in mind. Okay, he plants 5 more turnips. So turnips is a kind of vegetable, than cabbages. And now write an expression for the number of turnips. Well, let's have a think. Let me get my normal pen. So, if he has M lots of cabbages, and he plants 5 more turnips, then he's going to have M, because it's just a number, M, plus 5. That will tell you how many turnips he or she has. Okay, so I'll go through that again. He's got M cabbages, say M is 7, then he would have 12 turnips. M was 9, then he'd have 14 turnips. M was 2, he'd have 7 turnips. So the amount of turnips he has, the number of turnips he has, is whatever M is, and we add 5, which is our answer. So the number of turnips he has is M, and then we add 5. Okay. So we've got an expression now for turnips, and we have an expression for cabbages. Now we're going to use those. So the gardener has planted 15 vegetables altogether. How many cabbages did he plant? And this is where people go, whoa, okay, I've maybe done the first part, okay, that was fine. How am I supposed to know the number of cabbages from the total number of vegetables? I mean, what is this? Well, let's go through this logically. So, get my lovely pen out, my trusty pen. So, we've got 15 vegetables together. Let's work out how many cabbages and turnips we have together. Well, we've got M lots of cabbages. We have M plus 5, because remember, whatever the number of cabbages is, there's always 5 more turnips. And if we add those together, so this is the number of cabbages, but this is C, I'm going to put a C there for cabbages, and let me put a T there for turnips. If I add those together, let's put a plus there, I'm adding them together, that's equal to how many vegetables there are in total, which is 15. So I'll go through that again. M represents the number of cabbages, M plus 5 represents the number of turnips. If I add those things together, that will give me the number of vegetables, which is 15. Okay, we can do a bit of simplifying at this point. So M plus M, well, that's equal to 2M. Then we've got a plus 5. And that's equal to 15. So now we've got an equation out of nowhere, which we have solved in step 2. So now we've reduced it from a step 4 problem, a fairly difficult problem, to now a normal step 2 problem. And now we use exactly the same method that we've done many times before in part 1 and the start of part 2. So we've got plus 5. What's the opposite of plus 5? That's going to be minus 5, but we do that to both sides of the equation. So this cancels with this. So we get, I'll try and go through this fairly speedily. So 2M And then we've got 15 minus 5 is equal to 10. And then what's the opposite of timesing by 2? Well, we want to divide by 2 on both sides of the equation, like so. Let me get my red pen back again. There we go. So this cancels with this. Then we get m is equal to 5. And remember, m represents the number of cabbages, which is what we want. So always check the question. If we wanted turnips, we'd have to add 5 and get 10. So make sure at the end of the question you write exactly 5 cabbages. Okay, so you make it very clear to the examiner, the person marking your exam, could be me, that it's exactly 5 cabbages. Okay, make that really, really, really clear. Okay, so hopefully you found that okay. I animated the answer as well there. Okay, so in total, here's m cabbages and m plus 5. It's where this equation comes from. It's the same way I did it here. And then this is a slightly different way of showing the working. Rather than using arrows, we literally just put the calculation on the side. That's another way of solving equations. If you like that, use that method. It's absolutely fine. And it gets us to the same answer, as you can see. So we get m is equal to 5. Okay, if you're still struggling with that kind of question, first of all, go through this example again. So rewind, go back a few minutes, 5 minutes, and go through it again. Absolutely fine. Not everybody gets things the first time. We'll tell you about my driving lessons, but I will leave that for another day. Just make sure you really understand that. Okay, so here are 4 questions for you to have a go at. Okay, so see how you get on. Okay, I will then go through the first question with you. Okay, so have a go at questions 1 to 4. I will do question 1 with you after you've attempted these questions, but they're obviously for people that are absolutely happy with this concept, and have a go at questions 2, 3, and 4. Okay, so let's go through question 1. Yes, I do want to keep my annotation. So let's just get to these questions here, making sure it doesn't auto-save. So let me just go through question 1, and I will stop the video there for today. So let's take my red pen, my trusty red pen. So Sally has F bags of Lego. Each bag contains 22 blocks. Write an expression for the number of Lego blocks Sally has. So say I have 3 bags of Lego, then I'd have 22 times 3 blocks, which is 66. If I had 2 bags of Lego, then I'd have 22 times 2 blocks of Lego, which is 44. So my expression for the number of Lego blocks, let's call that n for number, well, that's equal to F, so how many bags I have, times the number of blocks in each bag, which is 22. Of course, this is kind of ugly algebra, so we want to make it look pretty. So instead of F times 22, again, good algebra, we write it as 22F, like so. Okay, so this time we're timesing because we've got F bags of Lego. Each bag has 22 blocks, so we're always multiplying up depending on how many bags we have. Okay, question B. So John gives her 9 extra blocks. Write an expression for the number of blocks Sally now has. So something has changed from what we just worked out to what's just happened. So John has now given her 9 extra blocks. So our new n, let's call that m, which is a different letter. Well, we've got however many blocks we had before, so that's 22 lots of f. See how these questions build from one step to the next. So it's important to make sure we're getting each stage right as we go along. So we've got 22F, but we've got 9 extra blocks. That means 9 more blocks. So we need to add 9 to what we had earlier, and that is our expression then for the number of blocks Sally now has, 22F plus 9. And as you probably are going to see with these questions, then we're going to get some kind of equation in part C. So Sally now counts her blocks, and she has 119 of them. We now need to use this information to form an equation and work out how many bags of Lego Sally started with. So we take our expression, so that's 22F plus 9, like so, and that's going to be equal to the number of blocks we have, which is 119, like so. And now suddenly we have an equation that we can solve, and we approach in exactly the same way we've done all the previous equations. So we look at the number next to the F, that's the plus 9. What's the opposite of plus 9? That's going to be minus 9. Okay, so we do that to both sides. This cancels with this, so we are left with 22F, that is equal to 119 minus 9 is 110. Okay, and you can probably see where this is going. So similar to an example I did in part 1 actually. So what's the opposite of timesing by 22? Well, we can divide by 22 on both sides of our equation, like so. Now I already know what the answer is, of course, so this is equal to F. But then you're asking me, right, well, how can we do 110 divided by 22? Well, again, you can always use one of these, calculator. So it's a calculator exam, use a calculator. If we don't have a calculator, then we need to do similar to what we did before. We need to write down our 22 times table. And this is where I used blue last time, so I'm going to use blue again. There we are. So let's write down our 22 times table. So 22 is our first number. If you add 22 to that, that gives us 44. This is actually quite a nice number. Then we get 66. Then we get 88. And now we have to think here. What's 88 plus 22? Well, 88 plus 2 is 90. 90 plus 20 is 110. Ah, perfect. We've got the same number. So let's count how many numbers we had to count along. Let's use a different colour. Cyan, why not? So this was 1, this was 2, this was 3, this was the 4th multiple. Aha, and we have our 5th multiple, which is 110. So our answer, going back to my traditional red, is going to be F is equal to 5. Okay, so we haven't finished the question yet. Okay, this is really important because we haven't written down how many bags of Lego. So F is 5, so our answer is she had 5 bags. Oh, that's a terrible G, sorry. 5 bags of Lego. I'm trying to do joined up writing, that's probably not the best idea in the world. There we are, 5 bags of Lego. Making sure you write the answer very, very clearly. The examiner has no choice but to give you all the marks in that question. Okay, so that's question 1 there. So if I back out of there, I need to get my automatic. There we are. I like to keep everything, it's good, so you can always look at these notes later on. I wonder if I can undo, good. So I'm going to finish off the video with going through question 2. So let me just do that now. So question 2, you don't want to see this or this. So let's shift that up. And then in my next video, ooh, that's not good. Right, so how am I going to delete that? That's a good question. I'm going to use the classic text box and change the background. This is a nice little trick if you don't know this on a computer. If you want to get rid of particular parts, if you just do a solid fill and make it white, there we are, and it all disappears. See? Very smart. So let's go through question 2. This is a bit trickier, so this is why I want to go through it in the video. So Michael gets paid Y pounds per week for his paper route. That's like delivering newspapers, basically. After 4 weeks, he gets paid, but £2 is deducted for lateness. That is a problem with people. They're late to these things, and that's why they lose money. That's a good life lesson. Write an expression for the amount Michael gets paid. Okay, so let's see if we can work this out. So I'm going to use P for getting paid, makes sense. P pay packet. So P is equal to, let's work this out. So he gets paid Y pounds per week, and he works for 4 weeks. So if he got £5 for 1 week, then you get 5 times 4, £20 for 4 weeks. If we had Y is £3 a week, then after 4 weeks it'd be 12. So we're taking whatever this number is, Y, similar to our first question, and we multiply by 4, because it's 4 weeks. Of course, this is bad algebra, so we like to write this as, I'm going to use an arrow, you'll see why, 4y. However, this is not the final part of the story, okay, because we also take off £2 for lateness. So we need to minus 2, because he gets £2 less than whatever he made over the 4 weeks. So our answer for P, I'm going to be very mathematical here and rub out this part, because that, strictly speaking, is not equal to P. So our answer is 4y minus 2. So 4 weeks, you multiply it by y, my pen, there we are, and then we take away that £2 for lateness. So P is equal to 4y minus 2. Okay, now similar to our previous question, when he opens his pay packet, he finds he has been paid £22. Now we need to find how much he was paid per week. So we take our expression for the total amount he was paid. These questions always build up in this kind of way. And whatever he was paid is equal to £22. So this is equal to 22. That's that critical step you need to make from worded question to normal solving algebra. And from here, we approach it in exactly the same way we have done before. So the opposite of minus 2, well, that's going to be equal to plus 2 on both sides of my equation. I will try and go fairly speedily again through this, so these cancel. So we're left with 4y, and then 22 plus 2 is 24, and then we want to divide by 4 on both sides. Divide by 4, that crosses out with this. Making sure we do the same to both sides, just take your time. I'm just going through it quickly so you can see the answer. Red, so we're left with y is equal to 24 divided by 4. So how many 4s go into 24? 4, 8, 12, 16, 20, 22, 24. That makes, I didn't count, 4, 8, 12, 16, 20, 24. 6, there we are. Okay, so we get 6. But again, we want to write the answer clearly. So how much Michael is paid per week? Well, 6 is not actually the answer here. He is paid, I know this is difficult for people not from Britain to write a pound symbol, but the answer is £6 per week, which is not actually that much for a paper round. You'd hope for a little bit more, wouldn't you? But there we are. That's our answer for that question. So that was questions 1 and 2 done. With my next part 3 video, I will show you the answers for question 3 and 4. So just tell you what the answers are so you can check your work. I will then now look at geometric problems. So we've now looked at worded problems. Now we're going to do the same kind of approach but take a geometric problem. So a triangle and some angles and then work out an equation, or even a quadrilateral or pentagon. So we're going to sort of drift into geometry and algebra, some kind of mix between the two topics. Okay, hope you enjoyed the video. One thing I would like to do before I disappear off this video is just give you a bit of a challenge. So this is what we're doing next time. So here we are. So if you'd like a challenge to do, this is called an algebra pyramid. So this is an extra task you can do, and you need to give each expression in its simplest form, and these are essentially building blocks. So let me give you an example of what's going on. Let's use my trusty red pen. So if we take 2a and minus 3c, then if we add those together, we get the next block above. So this becomes 2a minus 3c. Okay, if we work backwards, we have to take away. So 4a minus 2a is 2a, but the minus b stays the same. And you'll notice if you work upwards instead, you draw a little arrow, add those together, we get to this. 2a plus 2a is 4a, then minus b plus nothing, or plus 0, is minus b. So, if you're looking for an extra challenge, have a go at these algebra pyramids, see how you get on. You have to work backwards and forwards with these more difficult algebra pyramids. Okay, bye-bye for now.